you very much. It's a pleasure to be here. So in this presentation, I will talk about some of the activities done in the context of the Impressor project, which focus on the semantic indexing of historical newspapers in order to support their exploration. I will first give a brief overview of the Impressor project, trying to give the challenge, what we do, what does it take really to work with historical documents. And then I would like to have two spotlights. The first one on a long endeavor, which is a hype evaluation campaign on evaluation of named entity processing system on historical document. And a second spotlight on a very recent experiment we did where we asked LLM to post-correct poor OCR. So we are dealing with newspapers in the Impressor project, and newspapers are an extraordinary window into language, history, and culture of past societies. They have been published since centuries, and they record all kinds of events. And as such, they reflect many things. They reflect how contemporary reacted to their past. They also reflect normalities of the past, such as which were the value, the hope, the expectation, the fears of a certain time period. And obviously, they also reflect the context in which they were produced. So they kind of keep track of the big and the small data, and they hold a very diverse, dense, and continuous body of information, which is of interest for many researchers and in particular historians. And as we know, if 10 years ago one needed to turn a lot of pages to read millions of articles to find something, nowadays it's much easier because thanks to digitization, we have many online portals where users can see facsimile of documents, hear newspapers, and also search through the transcription of the documents obtained thanks to optical character recognition. However, this is not always satisfying to have keyword search because we have too many search result hits. We have also negative result. And if paradoxically we had millions of documents before, today searching through millions or thousands of gigabytes of data is not easier. So perhaps we can ask if it's a gold mine or a coal mine that we have here. And actually, if we discuss with people, usually researchers or researchers in digital humanities, they would like much more than keyword search, such as help me to filter my content by the type of the document I have or by its thematics. I would like to be able to deal better with OCR noise, or to be able to distinguish with John Smith the politician versus John Smith the butcher, and also to compare the flow of text across the corpus and perhaps across boundaries, etc., etc. So we can do much more, and this was the starting point of the Impressor project, where we asked ourselves how we could enable semantic indexing of historical newspapers and their exploration on a large scale. So this was the first project which was conducted between 2017 and 2020. We had the second project which just started now, and the first one was done by 3 institutions: University of Zurich, University of Luxembourg, and EPFL, and we also had the support of various cultural heritage institutions. Behind the project, and I'm really talking on the behalf of the whole team, but there is a whole team which is very interdisciplinary, composed of people coming from NLP, from digital humanities, but also web designers, engineers, and obviously historians. And the plan of our project was, as I said, to enable the exploration of historical newspapers, but in a nutshell here, first we start with collecting sources from archives of different countries, in our case Switzerland and Luxembourg, so we end up with documents in French, German, and Luxembourgish. Then once we have the data, we prepare them for processing, and we try to apply NLP techniques to extract information. And here what is at stake is really how we can adapt NLP tools on historical, challenging, noisy historical documents. And once we have the data, we need to make it processable, explorable, by historians, by other researchers, so that they can conduct their research. And this exploration needs to be fit to their historical research workflow. That's why we design an interface targeted towards historians. On this way, we encounter 5 challenges that I will briefly discuss here or present. The first one relates to digitized newspaper silos with 3 main issues: coverage, accessibility, and real data acquisition. The first one regarding coverage, a survey showed that libraries, sorry, can I come back? Don't know how I come back. Sorry, I clicked too fast. A survey shows that libraries had digitized 10% of their holding, meaning that the digital landscape of newspaper is quite fragmentary, and we need to keep this in mind. The second issue is related to access right restriction. If a newspaper are digitized, it doesn't mean that we can have the right to work with it, as it was mentioned just before. Here is the overview of newspaper in Europe digitized, and here is the one which are open in open access. So we cannot have it all. And even if we have the right finally to have it, then it's very difficult to really acquire. There is not such a central catalog in Europe or even globally which lists which newspaper exists, with which quality, digitized, in which format, etc. You need to do tons of Excel sheets, and it's very tedious and time consuming. So overall, with this silo, it's really that if you want to build your corpus, you have to go through a digitization, a data acquisition crusade, and the amount of effort that you deploy to sign convention, to have the right to use this data, all this administrative effort really is comparable with the technical development. Then the second challenge we face is that once we have the data, we are happy, but we realize it's big and messy. So what do we have? It comes from digital archive. For newspapers, we have three types of data. First, the OCR transcripts, which come in different formats. Then the image, the scan, which come in different formats. And the metadata, which also come into different formats. So in order to be able to just read these things, we need to transform everything into a processable data format and to bring to the same standardized format. And on the way, obviously, we normalize, so we are at risk of losing information, which perhaps historians do not like. And we also encounter a lot of inconsistencies. So this, I don't spend too much time here because I do not have the time, but I really want to highlight that before just reading the data, we need to prepare it, and there is a whole world of hidden steps. And this step is really, really important. It's painstaking, it's invisible, but it lays the ground for everything. And we learned that we should not trust any data, even the one we have done ourselves, produced ourselves, and caring about quality in this big data context is really not easy. Finally, once the data is ready to be processed, we are happy to start processing, but then that comes the third challenge, which I think is the main topic of here, is that we deal with noisy and historical text. So here the problem is that, as we know, NLP on historical document is hard for four main reasons, which I will briefly highlight here. The first one is a historical variety space. Newspapers per se are complex objects. You can find articles about everything, but if we zoom on and we look at the level of the library or the archive, what type of document we can find there, the time period they relate to, the language they are, the nature is really super diverse. And this diversity is obviously a challenge for NLP, which needs to adapt to new data all the time. So if this transferability problem is not new in NLP, because you will tell me, yes, today in contemporary document, we also have a large variety of documents. In today's application, the scope and the focus of NLP is rather on a certain type of application, usually commercially driven. But if you were NLP in the 18th century, you will have the same type of variety. But the main difference with contemporary NLP that I want to highlight is that researchers in humanities and social science, they are potentially interested in the whole spectrum. So every document needs to be looked at. Every type of things is interesting, and it's not according to a commercial interest, but to historical interest. And then the second problem is obviously noisy input. I think it will be talked a lot today about this. So OCR really bring mistakes, and for human readers, sometimes we can guess the word which is there, but for machine, it's really a lot of out of vocabulary which are there, and then the feature space is much more sparse, and system can learn really badly on this. The noise in documents is really annoying because it's a moving target. The noise can be very little in one document, but a lot in another document, and it's not evenly distributed across all your documents. So you don't really know how to catch it. The third difficulty is dynamics of language, which is also well known. Historical language is very different from modern one because of the natural evolution of the language, but also because of orthographic reform. And last but not least, the three challenges which I cited are compounded by a fourth one, which is a lack of resource. Even though we have a lot of things which are digitized, it's not easy to work with it. We cannot build large language model or even small language model with historical data as easily as we would like. So overall, NLP legacy, the tool we have today, is completely orthogonal to what archive and libraries offers, and we are facing a huge time and domain adaptation problem. What I want to say is that none of these challenges is new in NLP and modern document, but perhaps with a historical scope, they are all combined together, and it's a bit of an explosive cocktail when you work with this. So in Impresso, I will not go into all detail, but we apply a series of NLP techniques and processing, starting with lexical processing, identifying the language of the document we have, normalizing the spelling of the word, etc., etc. We apply a quality assessment of the document. We try to recognize the thematic which articles are about. We identify named entity. We also identify passages which are reused in one document from one document or one newspaper title to another. We also compute image similarity to allow visual search. We also have a recommender system, key phrase extraction, and many other things. And we apply all this and we try to put everything in an interface which historians can use afterwards. And then comes the fourth challenge, is how to design this interface. Because new means of how we can accommodate these tools to historians so that they can conduct their research. So that's not easy. We really started from scratch, how to design this. And the answer to this challenge was to apply co-design and fast prototyping, where we regularly met with people from different horizons, very different horizons, and try to assess, evaluate, discuss what are the best solutions that we can find to really work with these primary sources plus the semantic enrichment. So we did a lot of experimentation, often starting from wireframes, such as here, and with a lot of time, with a lot of prototype, a lot of experiment, a lot of failures, and finally an interface kind of came, and it's really the result of a dialogue between many disciplines. And finally, that's the fifth challenge is if we have new ways to engage with content, it also means new ways of using it, and how. Here the main question is how historians could work with algorithmically generated and changing and certainly imperfect data. To address this challenge, we devised two guiding principles, transparency and generosity, which I will not detail here. Then I have a quick demo, which I think I will keep for the end of the talk if there is still remaining time. And I will jump to the first spotlight, which relates to our efforts to make named entity processing system more robust to historical document. So here we kind of designed a series of evaluation campaign or shared tasks named HYPE, with the objective to really kind of further foster the performance of system overall, because we realize there is not a lot of benchmark which exists for historical document, nor a scorer, and we wanted to work on this. So to enable performance comparison and on the long term to foster efficient semantic indexing. So in this series of tasks, we had 2 editions in 2020, 2022 at CLEF, and we are preparing a third one. We focus on 2 tasks. First, named entity recognition and classification. I think it's known for everyone, and also named entity linking. For the first edition, we work with historical newspapers, Impresso material in 3 languages. Here is the distribution of the statistics. Don't look at the statistic. I just want to highlight the fact that in our corpus, which is diachronic, there are 25%, almost 26 of mentions which could not be linked to any entity in Wikidata, which is quite a lot. And surprisingly, their distribution is quite even through times, meaning that there is not more nil entity in the past than in today. Overall, we had 13 teams participating in the challenge. I don't present the result, but I just want to present 2 observations. Is that whether we ask the question of the impact of the article publication date on the performance of the system, and for this we analyze the variation of the F-score as a function of time. The initial hypothesis here was that the older the article, the more difficult it is to extract and link the mention it contains. But in general, we observe that there is not seem to be a strong correlation between those two, as you can see with the plot on the entity recognition on the top and entity linking down. Time doesn't really have an effect on the performance. Then we looked at the impact of OCR noise. Here we evaluate on various noise level, and the level of noise here we're looking at the performance of named entity recognition systems whether and how it differs according to the noise which is in the mention of the entity. And we compute this amount of noise thanks to the Levenstein similarity distance between the mention as it appears in the text and one which has been manually corrected. And for both recognition and linking, we observe remarkable difference between performance for noisy and non-noisy mention, and we can see that all the box plot green, which have very little noise, all the systems perform way better. And as long as there is a bit of noise, it's kind of half their performance. So this is really affecting their performance. Then for HYPE 2020, the main outcome was that a neural-based system with strong resource can achieve good performance, but we need better system to better handle OCR noise, nested entity, and also entity linking. Then we move on to HYPE 2022, where the main novelty was the addition of a new document type. We wanted to go further than just the newspapers, and we added classical commentaries. And we ended up with more languages to propose to participants, and we also confronted them with heterogeneous annotation tag set and guidelines. In terms of data, the corpus started to be a bit more consequent. We kind of team up with other projects which also has annotated named entity data to build this benchmark. Some in a lot from newspapers and from the AGMC project on classical commentaries. Overall, I think it's a huge asset which you are welcome to use. It's a corpora which contains 78,000 annotated entities linked with Wikidata, which has kind of quite a lot of specificities which are challenging and representative of historical material. The main outcome on this is that transformer-based approach with strong pre-trained model kind of work better. And then if you really want to transfer to another document, to another language, you better have a good selection of your pre-trained model. I go quite fast in order to cover the last topic, but as a conclusion on HYPE, we kind of try to foster the robustness and transferability of system for named entity processing on historical documents. And we kind of had the occasion to release quite some data on this and a score that you are welcome to check up. Then finally, as a small experiment that we conducted very recently with a few colleagues, we explore whether LLM are capable of post-correcting OCR. So that's a very recent work which has been presented just last week. And I think we all know the problem. It's all about OCR. So you have a text and it contains mistakes, sometimes big, sometimes small, a lot, not a lot. And as everyone, we all try to put this into ChatGPT. So please, here is a text. Can you correct and identify the mistakes and please correct it? And indeed, it can correct not everything, but it gets the stuff. And we are all like, oh, super, perhaps it's a solution to all our problem. And but what we wanted to do is this study, was to explore whether this really, really works beyond anecdotal observation in individual brothers, so to do a systematic evaluation on OCR benchmark. So we ask ourselves whether LLM, which have a good capacity to understand language, can really help to rewrite historical texts that have been poorly transcribed. In terms of objectives, we really want to understand whether, to what extent, and under which condition LLM can correct OCR. So we want to judge on the ability to correct. So do they improve? Do they degrade the performance? We want to understand how sensitive they are to the input text, if it's in a certain language, of a certain document type, if it has a certain noise level. And we also want to know on the big picture whether it could be a viable and cheap solution to recorrect all the million of backlog of noisy historical documents we have. Not spending a lot of suspense, I just want to say it doesn't work at all. But first, the approach we have, so we start with a set of transcription post-correction, which contains, on the one hand, faulty automatic systems transcription, and on the other hand, the ground truth. To reflect the diversity of archival material, we consider various benchmarks which cover different languages, different document type, and as well as different transcription origins and quality. Next, we prepare this benchmark in order to standardize them in their different format and to make sure that we kind of have the same text representation level for each of them. And once we have our data ready, then we ask the LLM, we prompt the LLM to correct them. And here we experimented with different prompts, with different models in zero and few shot setting. and we applied or not post-processing to the output of the LLM. And finally, we evaluate whether the correction generated by the LLM are good. To do this, we measure whether the LLM post-correction generated by LLM, therefore, are better or worse than the original system, and we do so by having a relative improvement score, which is based on the comparison between Levenshtein distance between the former original transcript system and the new output of the LLM, both compared to the ground truth. We also had a small manual analysis. So which dataset do we consider? As mentioned earlier, we want to test the post-correction capacity on a diverse material. Thus, we consider 8 post-correction benchmarks. We have at the bottom data coming from automatic speech recognition, HTR with 2 datasets, and then we have a lot of data coming from OCR of different type of documents and different time period and different origin. So overall, this benchmark kind of really provide challenging material with LLM. And in addition to the variety of error type and language, you have problems of text segmentation, etc. So as much as we could, we bring all text to 3 text unit level with region, sentence, and lines, as you can see here, and we also compute percentage quality band of OCR. In terms of model, we consider overall 14 large language models coming from 4 model series. So the GPT is the OpenAI series with 4 models and the Bloom from the Big Science project in 3 different sizes, Bloom Z as well in 3 different sizes, and then OPT and 2 Llama. In terms of prompts, we consider 4 prompts. The basic 1 and basic 2 are, as the name indicates, very basic, and then we try to provide more guidance by telling the LLM what is the origin of the text he has to correct, and then by trying to make him output the stuff a bit more cleaner by giving us some instruction about formatting. Here is the result. I forgot to say that the relative improvement score range from -1 when it's degradation, +1 when it's improvement, 0 when it doesn't change, and you have here the color code, and everything is in the red. On the x-axis, you see the different corpus, and on the y, the different model. So everything here is aggregated, but it gives a feeling, the trend. I want to say here that we look at the best configuration because we had 3 text unit level, 8 data sets, multiple quality band, 14 model, 5 prompt, 0 a few shot settings, so it ends up with many configuration. And in the end, this is the best that we found. So in short, it really doesn't work, and the challenge is really to find what can help to really improve the things. So I will show 2 more things before concluding. In the things that we try to understand what works best, whether was one of the question whether it helped to post-process the output of the LLM. And here you see in the hash bar the improvement score for the post-process response, whereas the non-hash bar are the ones which are non-processed. And you see that each time post-processing the output helped, but we are still in the minus. There is no improvement. And you can also see that between GPT-2, 3.5, and G.4, the performance is better, meaning that the initial performance is better, then it's less and less post-processing. Then we ask ourselves the question, what is the best prompt? So here it's, what we see here, it's a box plot for each model on the x-axis, and then you see different colors for each prompt. The basic are blue and brown, and the rest is for the complex prompt. And everything is in the degradation, but what we can notice is that it's really helped to give more detailed guidance about what to do because the complex prompts are better than the basic one. Still, there is not a clear winner for the complex one. Then we wanted to finally understand what are the mistakes which LLM do into trying to post-correct this. So we sample some pairs of LLM corrected and ground truth pair across all data sets, and we try to categorize them. It was a quite difficult work because we kind of devise a category as we are annotating. And you see here the main classes of this, with the first one and the fourth one are nothing to do because it's unanswered prompt or instance of incorrect ground truth, but the category C2 and C3 kind of deal with good answer and kind of C2 is slight deviation from the ground truth, and C4 is strong deviation from the ground truth. So the slight deviation could be still considered as good. Here, that's to kind of more detail about this. And what are the proportion of these categories among our annotated result item? Here you see the overview for the slight deviation on the left and the significant deviation on the right. Among the slight deviation, we can observe that Llama, which is in blue, has a tendency to add more text than necessary, and that GPT-4, which often tries to embellish the rendering of the system, as we can see in the brown color. And then on the right, for the significant deviation, the most mistake that models do is that they hallucinate. The second mistake is that they paraphrase, and finally, they often translate the text. So overall, large language models really struggle to accurately correct historical document transcription, and they kind of worsen the whole stuff. So don't do this or do it differently, not with this prompt. It's a first exploratory study to really evaluate whether it works, but that's the answer. So that was part of one of the small experiments in the context of Impresso. To come back to this project, we are starting the next phase of the project, where we will now focus on enriching and integrating more newspapers from European cultural heritage institutions, as well as with radio source into a single semantic space. And I will stop here. If you want to know more, there is this link. Thanks a lot.